Okay, so now let's have a look at this question here. What is the limit as x approaches 3 of 2x minus 1? All right, so here 3 is playing the role of c in the general case, and our function is f of x equals 2x minus 1. And here's the graph of it. It's, of course, a straight line, a very simple function. And what we're interested in is what's happening to this function as the x value approaches 3. Well, because it's such a simple function, we can see what's happening. That as x approaches 3, the function's value is going to approach the value of the function at 3, which is 6 minus 1, or 5. So we can see very clearly that the limit as x approaches 3 of f of x will be equal to 5. Now let's try to understand that in terms of the epsilon-delta story. All right. So if we were going to approach this with an epsilon-delta point of view, what would we do? First of all, let's define the function that we're interested in. So f of x is 2x minus 1. And let's state what it is that we claim. We claim that this limit as x approaches 3 of 2x minus 1 is in fact 5. Okay, so what that means is that for any epsilon, i.e. for any epsilon greater than 0, there exists a delta greater than 0 such that if x is within delta of 3, then the function differs from its limit by something less than epsilon. All right, so that's the standard definition interpreted now in this special case. And let's have a look at what it actually means geometrically. So for example, suppose, to illustrate, that epsilon is, say, a 1. So in this picture, I guess we should maybe extend this a little bit. Let's make it up there so we can also see 6. All right, so if epsilon is equal to 1, it means that we're talking about a range of 1 around the limiting value of 5, which is L. So in this case, the limit is L, or 5. So we could ask, how close does x have to be to 3 in order to guarantee that the function's values are within this band of epsilon, which in this case is 1, around the limit L? We can see geometrically, perhaps, what we need this epsilon to be. So if we sort of kind of go down here like this, maybe we're thinking that a delta of about a half would work. That if we're within a half of 3, then we're within 1 of 5 in terms of the function's values. So we guess that delta equals, say, 1/2 might work. Let's see if we can establish that. So suppose that x is within a half of 3. Then what can we say about f of x minus 5? Well, then f of x minus 5, well, what is f of x? It's 2x minus 1, subtract 5. So this is equal to 2x minus 6. Can we relate this to this? Well, we can, because this is just 2 times x minus 3. If we know that x minus 3 in absolute value is less than a half, then this is going to be less than 2 times a half, because x minus 3 in absolute value we're assuming is less than a half. and this is equal to 1, and that's what we want. So we've shown that if epsilon equals 1, then delta equals 1/2 fulfills the requirement of the definition, namely that if x minus 3 is less than 1/2, then the difference between f of x and L is less than 1. Okay, so that's a kind of a motivating particular example. Now let's see if we can write down the argument in general for a general epsilon. Okay. So let epsilon be greater than 0. We want f of x minus L, which is 2x minus 1 minus 5, to be less than epsilon. This is the same as uh, 2x minus 6 is less than epsilon, or 2 times x minus 3 is less than epsilon. That's what we want. And what we have control over is choosing an appropriate delta. So if delta equals epsilon over 2, then if x minus 3 is less than delta, then this implies that f of x minus L, which is 2x minus 3, that will be less than 2 times epsilon over 2, which is epsilon. So this proves, therefore, that yes, indeed, the limit as x approaches 3 of 2x minus 1 is, in fact, 5, as the diagram suggests. And we've shown that the key is to follow the Cauchy-Weierstrass idea. We pick an epsilon, which is in general just some number greater than 0, and then we try to find, in terms of that epsilon, we try to find a delta so that this basic implication is satisfied, that if x minus 3 is less than delta, then f of x minus L is less than epsilon. So I hope that illustrates this important idea of a limit in the Epsilon-Delta framework in this special case.